Hi, welcome everybody to the first chapter in the first book of the CCNA program. And let's get moving. So, we're going to talk about being globally connected. So when we think about globally connected, what do we think about? Well, the internet. So the first thing they want you to do is, you don't have to do this on paper, but how does the internet work? So in your idea, I guess, how does the internet work? How do I get something from here, from my PC, to a web page? So take a couple minutes, pause the video, and think about that, and then we'll move on. All right, really, the internet is just a collection of routers and switches. Basically, service providers have central offices, or they have little remote offices like all over in their area. And then they have large connections between the offices through fiber cable. And then when they sell you internet, basically you connect to the nearest local office, and they connect you in. And then from there, they route you through their offices to eventually another provider's network that's closer to the web server that you're at. So basically, the internet is just really kind of a collection of routers and switches at provider network locations throughout the world. All right, and if you want to see them or see how many things you hit, if you open up a web browser, so if I open up... how do I do that on this crazy computer? There we go. So if I open up a web browser, and let's say I want to go to Google. So first thing I need to do is I need to find the IP address of Google. So everything works by numbers or IP addresses on the internet. But there are friendly names that help us to remember them. Like if I had to remember like the IP address of Google, I'd probably never go there. But if I just typed in Google, then that works for me. So whenever we type in a friendly name, it gets converted to an IP address. So if I ping www.google.com, it'll show me the IP address. So here's the IP address of google.com. Now that I have that IP address, I can actually do a trace cert and then type in that IP address. Or I can even just type in www.google.com. Either way, they should work. So this first router I hit, this is my router in my house, and then eventually it goes to the provider network, and it shows me how long it's taking to hit those. And you would think 8 milliseconds would be a little faster than this. So this is the first router on my provider's network. And then at that point, I have no idea where it goes. So I'm going to move this out of the way. So you can see here, boom, boom, boom. So I went all over. I hit Chicago. Now I'm in southern Ohio. And I went to the Midwest. I went to Chicago. And it might not be the same route every time. So I'm going to put this here. We can kind of compare if anything's different this time. Again, I guess it all just depends on your provider. No, pretty much I'm same exact time. But you get the idea. So these are all the different central offices and routers that I'm hitting, through the different provider networks. And just to go from my house to Google, I might hit 3 or 4 different provider networks. All right, so networks in our daily lives, welcome to the world where we're more powerful than ever, blah. Welcome to the human network, blah. I don't know why Cisco puts these slides in. It drives me nuts. So, it says, we live in a world we barely imagined 20 years ago. Well, 20 years ago, I was thinking we're going to have some jetpacks. So, I'm still disappointed. But the thing is, like the internet and how that really kind of opened up the world and different things. If we think about what technology was 20 years ago, this is what we were using. Maybe even 30 years ago. No, nowadays, nobody has a landline. And how many phone guys are out of business because they didn't convert over to the network, the data side? And this was a computer with a big fat CRT monitor. Ugh, and we had floppy drives. My very first IBM computer had no hard drive. It was just floppy drives. So every 5 minutes you were popping in another floppy drive. It was miserable. But I digress. So think about how you got information 20 or 30 years ago. When I was growing up and we wanted to do research for something or we wanted to learn about something, you either had to go to the library or you had to go to your neighbor's house who had a set of encyclopedias. And that was it. There was no internet. There was no instant communication. If you wanted the news, you had to wait till 6 o'clock and you ate your dinner and you watched the 6 o'clock news. How'd you communicate with family and friends? Obviously we sent regular mail and we sent letters and cards, things like that. What'd you do in the bathroom for entertainment? We had magazines and we had magazine racks in our bathrooms. Nowadays, like in my house, we actually have an iPad that my wife got on a contest. So Anyway, it's the bathroom iPad. Never leaves the bathroom, and we all just use the iPad in the bathroom. And then how'd you watch TV 20 years ago? 20, 30 years ago, we had three channels, like 3, 5, and 8, and then there was like one kind of weird local station, 43. But now everything's different. I can watch whatever show I want on demand without commercials or however. So way, way different than things used to be. We actually had an antenna tower on the back of my house growing up to get the actual airwaves and stuff, and all TV was free. So, there's no boundaries. Cisco refers to the impact of the internet and networks on people as the human network. Blah. Obviously, networks support the way we learn. Networks support the way we work. And when we think about working nowadays, there's so much that's different than it was 20 years ago. We can text, we can do social media, tons of collaboration tools. We can post stuff on blogs, find information from wikis, listen to podcasts, all while we're working. It's kind of different. More about the way we work. Employee training is becoming more cost effective. I don't know about that. All right, so networks support the way we play, and this is big, obviously. Online games and mobile games are huge. I don't know if any of you guys play Clash of Clans, but it's a free game, and the company that makes it, Supercell, they have like 3 or 4 of the top mobile games, and all their games are free, but they sell items in the game to make things go faster. So you can either try to work through the game to make enough money to buy an upgrade, or you can just buy these gems and get the upgrade right away. And they make over $1 billion a year, with a B, billion, just selling the upgrade tokens. It's amazing. So, then Cisco has another activity, hey, research collaboration tools. So, what collaboration tools do you use? So, think about social media and Facebook and how you can collaborate on there. And actually, even like when it kind of first started, Microsoft Office was a huge collaboration tool. Microsoft Outlook, you can schedule meeting rooms, you can schedule meetings and invite people. There's a lot of collaboration that goes into Microsoft Outlook. All right, then we can share documents with Google Drive. We can have web meetings, and even as far back as 15 years ago, we had a doctor that lived about 20, 30 miles away from the main office. And we were able to set him up with a web meeting stuff so that he could just do his meetings with the corporate office, that way, and save gas. Then we have wiki pages, but you don't want to trust those. You never know what somebody's going to put on a wiki page. All right, so networks come in lots of shapes and sizes. Back in the day, we used to have LAN parties. And I still with a group that we still do. So the first Friday of every month, we all get together, and some guy brings in a switch, and everybody plugs in the switch, and we all play like Call of Duty or something together. So that'd be a small, or at your house, your PC connects to the router, and then your TV, your Roku stuff connects to that too. So we have small office or small home networks. We have small office home offices for a lot of people that work at home and they have their office at home. We have small and medium businesses, or medium and large businesses, and then we have the wide, big networks. Woo! So you might hear this word SOHO, and that's small office, home office. There were when telemarketing or teleworking first kind of became big, they pushed a lot of hardware called SOHO boxes and SOHO devices geared towards the small office, home office. And you'll still see that kind of mentioned out there in the world today. All right. So when we think clients and we think servers, we think of a server as a large, a huge PC that kind of holds all this data. But in networking, client and server really is a role. Anytime you're sharing information from your PC's acting as a server. And anytime you're receiving information from a remote source, your PC's acting as a client. So it's possible for your PC to be acting as a client and a server at the same time. If I'm downloading a document from a web page, I'm a client, but if I'm also sharing an MP3 with my buddy, then I'm acting as a server. So when we think client and server networking, we're thinking about the roles. Where's the data stored at, who's sharing, and where's it going. All right, and then peer-to-peer networks. This is like where there's no central authority. Everybody kind of has their own individual stuff. So if I were to plug into my buddy's PC with a crossover cable, I could set passwords and stuff so he could access my stuff, or he could go through my PC and go to the printer, things like that. So that's peer-to-peer. So there's no centralized administration. Obviously, it's not very secure. It's not scalable. The performance is going to be slower, things like that. And anytime you download, years ago we used to use programs like Morpheus and things to get MP3s for free. And what that did was it actually added you to their peer-to-peer network, and it put a file on your PC that they then had access to, and they would actually share your MP3s out to everybody else. And then when you would download something, it would download into that same folder. So it's very dangerous. All right, moving on. So LANs, WANs, and the internet. So in your book, if you go down to the information section, the comment section, you'll see I listed the book that we use through this phase 1 or CCNA 1. And on this first page, or this page here before then they get started, I have all the different device icons. And these are very important. You're going to see these a lot, especially in the book and when you get a job on the real world. Most places have their networks mapped out, poster size and laminated to help them troubleshoot and do different things. So these are probably the most important icons. You know, a router is always a round box with arrows pointing in and out. A switch is always a square with arrows pointing in and out. A multi-layer switch is usually a square with a circle in the middle, and a multi-layer switch is just a router and a switch to combine. Then a firewall, and your firewalls come in, like sometimes they show this, sometimes they show this. Wireless router has these two little things sticking out of it. Workstation, file server. UD Express is a Cisco thing for voice over IP phone systems. I don't think you'll see any bridges anymore, but if depending on how big of a company you are at, you may see an ATM or an ISDN switch. But for this book, make sure you know what a workstation, a file server, a switch, and a router looks like. All right, and again, there's a program called Visio where you can map out your network. Now, this is a very small, kind of freaky network with some really weird icons. You can actually go to Cisco and look for Visio stencils on Cisco's website, and they can actually give you like the actual pictures of the Cisco devices, which is kind of cool. And I think you can do that with some of the other vendors as well. All right, so that's a small diagram that's not very detailed, but then you get into some of these big ones like, bam, what the frick? So again, everybody I know has a Visio diagram with their stuff, poster size laminated, in their server rooms to help them troubleshoot. All right, so as far as network components go, the Cisco kind of divides them up into devices, media, and services. And obviously a device is anything that any hardware piece of equipment. Media is what connects those different things, and then services are, again, services that you buy. So end devices, again, end user devices or end devices are where the network ends. Now we're talking about your PC, an IP phone, a printer. The line comes and hits your PC and it stops. Line comes, hits the phone, it stops. Line comes, hits a server, it stops. So whether it's a server, a PC, a printer, an IP phone, those are end user devices. All right, then after that you have intermediary devices, and these are devices that are kind of like that people don't see. They're typically either in the walls or the ceiling, and they help transport your data. So wireless routers, the switches, the regular routers, firewalls, things like that. And then we come to the media, and when we say media in networking, we're talking about the cable type. How does your information get there? Is it going through a copper Ethernet cable, a glass fiber optic cable, or through a radio signal through wireless? And each type of media needs a different NIC card, and a NIC card is your network interface card. So if I'm going copper, I need a card that connects to an Ethernet cable and will send stuff as pulses of electricity along the copper. If I have fiber optic cable, I need a NIC card that allows a fiber optic connection and sends information as pulses of light. And if I use wireless, I need a wireless card to send things as radio waves. All right, network representations, again, same diagrams and stuff, but you'll see end user devices, intermediary devices, and then they have different categories for the media. So that's wireless, typically your straight through cable, or your WAN media. All right, then we need to talk about physical versus logical. Physical is something you can hold in your hand or you can see. Logical is something that's kind of partitioned or different, and you can't really hold it in your hand. So in this example, think of your hard drive. You can partition your hard drive into drive C and D, but you only have one physical hard drive. I can only hold the hard drive. I can't hold the D partition because it's not a physical thing. It's just something I break up logically. So that's physical versus logical, and Cisco doesn't really do a good example on this. On this next slide, like here's their physical network and here's their logical network, and they're almost the exact same pictures. So a physical topology is the actual devices listed out in your network. And a logical topology is just how data flows in your network. So a lot of times in the logical topology diagrams, some stuff will be missing. Like you won't see a lot of the hardware pieces because they're just showing you like how information flows in your network. And it's something that you really should, like anytime that you're working in a company, you should understand how the data moves and where your biggest bandwidth paths are, things like that. All right, so the two common types of networks are LANs and WANs. So a LAN is local area network and a WAN is a wide area network. So anytime you have a router between two networks, you have a WAN. And if you don't necessarily need a router, then you probably have a LAN. So here, I've got some users, they connect to a switch, they connect to a multi-layer switch, then they hit a router and they go to a server. So all this here is a LAN. This is a LAN, this is a LAN. So these are just three different LANs. And when you connect them through a router, and the router has connections on more than one side with different networks, then you have a WAN. So the smallest WAN could be a small business that has a central office and a branch office, and then the largest WAN, well, obviously, is the internet. There's also MANs, which is a metropolitan area network. Some cities are putting in citywide wireless. Then you have a storage area network, where you store data in, and it's just like a device with a bunch of hard drives. You might also have, the military started coining this years ago, a PAN, a personal area network. And nowadays, like when we think of Bluetooth, that's like our personal area network. We're talking about it only transmits a couple meters, things like that. All right, so again, local area networks, they span very small geographical areas such as a house, a school, an office building, or a campus. They're usually administered by a single individual, and they provide high-speed bandwidth to end and intermediary devices within the network. All right, and then we have wide area networks, that span large geographical areas. Obviously I can connect from here to, the UK or something like that. So, and that obviously we're talking about the internet. So, anytime you connect two LANs together, then you have a WAN. So obviously the internet is the biggest WAN, and the internet's not technically owned by anybody, but that's not necessarily true. Like different service providers own different geographical areas. Like in my area, the only serious internet you can get is from AT&T or Spectrum, which used to be Time Warner Cable. And AT&T is terrible. Like I haven't had to deal with AT&T in about 12 years, and it's by choice because I hate AT&T. I've just had so many problems with them over the years, getting T1s installed, things like that, in my business. And then outside the business at home, I used them for a year, and I hated them for personal cable or internet. So I've always been using Spectrum, Time Warner Cable, but so that's really the only choice in my area. So it is kind of like they own that area, and you've got no choice, and they could do whatever they want. They could throttle your speed or whatnot. All right, and then we're going to talk about different types of internet kind of sites. So obviously your business could have an internet site, and that internet site's available to the world, and that's kind of where you sell your products and the world gets information about your company. But then you can have an extranet site. When you start a business and you go to CDW.com, CDW shares a portion of their website with you, just your business. And that's your business-to-business site where you do your ordering and stuff through CDW. And that's an extranet. So an extranet is when you have an internet site that you only share with certain suppliers or customers or collaborators. And most hardware suppliers like CDW or Insight will offer that to you as a business. And then we have intranet sites. And an intranet site is a website that's really only available to staff inside your business. Most companies, depending on their size, have an HR department that gives forms out through the internet or the intranet site, to request time off or do different things, make changes to your 401k, whatnot. So that's an intranet site. It's only available inside the company. Nobody can reach it outside the company. All right, so there's different ways to access the internet. Cisco is a global company, so they always talk about like all these technologies, and they may or may not even be popular or even available in your area. Like they still talk about DSL a lot, and I haven't seen DSL in years. Maybe it's just because where I'm located, but nobody has DSL. It's all you either get it from AT&T or you get it from Spectrum. All right, so small and home office connections, basically there's cable, which is awesome. It's high bandwidth. It's always on. Cable had a bad rep when it first came out because they used to kind of share the bandwidth. And at night between 6 and 8 o'clock in prime time, everybody would get on the internet, and then their bandwidth would go down. All right, but nowadays, cable, what do they call it? Provisions their network. So everybody gets what they're theoretically slotted for. All right, then there's DSL, and DSL, it's always on. It comes through your phone system, your phone lines. And then, again, that's not why it's not very popular today. How many people have a landline? Nobody in my neighborhood has a landline that I know of, and I live by several retired people, and they do not have landlines. It's miserable. All right, then if you're rich, you can use cellular, but who wants to use their cellular minutes? Years ago, back when you could buy unlimited minutes on your cell phone, people would turn their phones into Wi-Fi hotspots, and then everybody would connect to them, and it was kind of neat. Nowadays, not so much because you got to pay for that stuff. Then there's satellite. Satellite's really good. Like if you're in a crazy area, like we had a guy, and he was out like 30 miles from the city, way out he was down by the Virginia border. And there was nothing in his area that provides service for him. So he ended up buying satellite. And there was such a delay with satellite, by the time he would log on and it would go up to space and hit the satellite and then be transmitted back down to their central office and to our business, he couldn't log in. There was just too much of a delay, and it would always time out. So it was kind of a pain in the butt. And then there's obviously dial-up, and people are still using dial-up in businesses, but they're not really using it for internet connection. They're using it for a backup internet connection, or like they have dial-up connected to modems and they have the modems turned off, and that way if for some reason the internet goes out and they have a problem with their firewall or their routers, they can have somebody dial in and work on those devices. So we still see dial-up and modems in businesses, but they're typically used for maintenance or backup paths. All right, and then our regular business connections, years ago, and even as far back as 15 years ago, the central model was to build a headquarters and keep expanding the headquarters building. We have a big hospital system near us, and they would buy like a whole block, and they would tear down the houses and they would add more buildings. So then they have this like huge kind of campus. But that's not really the model nowadays. Now they've been buying other facilities throughout the area. They have a health and wellness center. They've got other little places, pharmacies, and dermatology offices. So it used to be we kind of did everything in one central location, but nowadays we're branching out. We're kind of spreading out with satellite offices. And to do that, you need dedicated lines between your central office and your smaller offices. Because you don't want to buy internet and email and everything and file services all for each branch office. You just want them to connect to your headquarters office and then access the stuff you already have. So that's why you can buy a leased line, which is like a T1 or a T3. A T1 is a private piece of copper between you and through a central office or provider network, and then connecting to your satellite office. And it's 1.5 megabits, which is pretty low as far as speed goes. And then a T3 is like 27 T1s all bundled together. So there's that. You could do DSL. Nowadays, what most people do, because internet bandwidth is so high, most people just have internet bandwidth. So let's say I bought a new office 5 miles down the street or 10 miles down the street. I would just buy them some kind of business internet, and then I would set up a VPN connection between them and my central office. So that's what we do now. So these leased lines and things like that and DSL are kind of going the way of the dodo. They're dying off just because the internet bandwidth is so available. I know Spectrum in my area, before they became Spectrum, Time Warner spent years just laying fiber all over our area. So now, we have fiber I have fiber all the way to my house. And then it converts to coax cable when it comes into my house. I could actually buy a fiber connection and pop it in and be fiber. But obviously they throttle my bandwidth, so I can't do that. All right, so then they talk about Packet Tracer. And Packet Tracer is a cool little utility where you can make networks and map stuff out. So if you've never seen it, it's nice. I cannot provide that to you. Packet Tracer is owned by Cisco, and you can only get access to it by joining an official academy. But if you look online, you can find Packet Tracer out there. There's tons of websites for it. So this is what Packet Tracer looks like. But nowadays, if you use the newest version of Packet Tracer, it also requires you to put in your username and password. With the Cisco Academy. So if you're going to get version 7, it's not going to work for you. But you can pop in routers, you can pop in switches, and then you can cable things. and then you can actually really do the actual commands and stuff. Now, Packet Tracer doesn't support all the commands, but it does support enough to get you through the CCNAs. But if you're going to go through CCNP, there's a lot of stuff you can do in Packet Tracer, but you're probably going to want to go to GNS3. GNS3 is an emulator that actually you have to have the iOS of the routers and load them into GNS3, and then they support all the commands and they do kind of almost everything. So for CCNA, Packet Tracer is great. It allows you to do a lot of neat stuff. But then once you go on to CCNP, you want to get GNS3. GNS3 is free, but then you got to figure out how to get the iOSs. And if your Google foo is really good, you can find that. But obviously Cisco does not allow that. They don't want you doing that. That's bad. All right, so we talked about Packet Tracer. So the network as a platform. All right, years ago, back when dinosaurs ruled the earth, we had different cables for everything. So for our computer network, we had Ethernet cables all through the ceiling. For phone networks, we had phone cables all throughout the ceiling. I was at a hospital, and then this is just like 12 years ago, where they had an old video system from their cameras and stuff. And so it was all coax cable, and they left that all in the ceiling. So their ceiling had tons of phone cable and coax cable still up there, because whenever they do new stuff, they just pop the new stuff in there. They just cut the old stuff and leave it sit there. It's kind of weird. So we had a different network or different cabling for each network, and it was terrible. So fast forward to today, we have what they call the converged network. And the converged network, we do voice, video, and data all on the same cables, which really helps to reduce our costs and stuff. All right, so then Cisco has this little lab where they want you to understand, survey your understanding of convergence, research ISPs, research local ISP offerings. And they used to have a thing where you could actually get quotes for different lines and stuff. I don't think it works anymore. But you understand a converged network is when we take data, voice, video, and stuff and put it all on the same network. And it's important because there were people that there were phone guys that had been phone guys for 20, 30 years. And now that voice over IP is kind of taken in and nobody's buying landlines, a lot of these guys didn't update their skills and they lost their jobs. All right, so moving on. So let's talk about network architecture. We're going to talk about fault tolerance, scalability, quality of service, and security. So the first one, fault tolerance. Fault tolerance is just how much of an impact will a failure have? If I have a failure, how many people or how many devices are going to be impacted? So basically, if we have a strong redundant network like in here, everything connects to this switch, which then connects to this router, and then has two different routers. So if this router were to go down, I could just reroute there and kind of get my stuff in there. But if this switch died, all of these people would be out. So that's fault tolerance. If I lose a piece of hardware, how many people are going to be affected? We had a building that everybody was connected to the main area, but then there was another wing that was added later on, and they had a fiber cable connecting the main area to this other wing. And somebody did something in the ceiling and cut the fiber cable, and then we lost that wing. But there was no backup data cable, or there was no fault tolerance for that. But you get the idea. All right, then scalability. Scalability is, how much can my network expand without having to add a bunch of new equipment or redesign the network? So when you build your network or you're building a new network, you want to think about, what's the growth? What's the projected growth? If I have 22 users currently and the business is growing at about 7% per year, the last thing I want to do is put in a 24-port switch because I know they're going to outgrow that in the first year. So I'd probably go with a 48-port switch. Just like when you buy phone systems, think about how many people, if I've got 500 people, I want to get capacity for 600 because I want to allow that network to be able to grow without having to go add new cards in there. The first time you ask for a quote is a lot easier than the second time. If I go and say, hey, I need $300,000 for a new phone system. And then after that phone system gets installed, I then go back and say, hey, I need $50,000 for some new upgrades. They're going to be like, what? Dude, we just bought you a new phone system for $300,000. We're not giving you another $50,000. So anytime you quote or you're building something, you're designing something, make sure you design it for scale. What's their projected growth? And a rule of thumb is 3 to 5 years. So think about their growth and make sure that it covers the next 3 to 5 years of growth for that business. All right, quality of service. Quality of service is just a way where we can tag traffic and say, hey, this traffic is more important than other traffic. When we think about internet, if somebody's browsing the internet or they're getting email, that's really not very time sensitive. You can drop a couple packets and it's no big deal. Then the server just asks for new packets and you might get a small delay, something like that. But we're all kind of used to those loading screens. But in a phone call, if you start dropping packets, you start getting static, you start getting dropped syllables and words and stuff, and it has an issue. So we typically have our voice and video traffic needs to have a higher quality of service or a higher priority than our data traffic. But it all depends. The finance guys may need a higher quality of service or higher priority on their finance information. So it all depends on the business that you're at. So the quality of service is just a way of saying, hey, here's how I can prioritize data. And we typically want to prioritize voice over regular data. All right, then finally security. With security, it's kind of odd. Companies will spend big dollars at their border trying to block all the bad guys outside, but they don't do any training and stuff inside. And actually, a lot of security things happen, or threats or incidences happen from inside the network. Somebody gives their girlfriend a CD that's infected with a virus or a keylogger, things like that. Or somebody gets fired and they talk to one of their friends and they give their friend something, or somebody gets a job at a place that they don't like as a cleaning person, they put keyloggers on the devices. So why companies don't spend kind of equal that stuff out between the outside and the inside is beyond me, but I know. All right, so 3 goals of network security: confidentiality, we only want the intended recipients to see stuff; integrity, we don't want the data to be changed on the way or altered; and then availability, when a user needs data, the data needs to be available. The network doesn't need to be down. And a lot of places that they give you bonuses based on the uptime of the network. All right, the changing network environment. All right, so new trends. They have this, bring your own device thing. I've never seen that anywhere but obviously, a lot of people bring in their own phones and their own tablets and stuff to work. And you have to make sure that they're secure, because these people, they will do the craziest stuff. They'll go home and surf a whole bunch of porn on their tablet. Their tablet comes in all infected, and now it's right past it's inside your network now, and it's trying to connect to your network. And then boom, you get all this stuff too. So a lot of weird stuff. All right, so bring your own device. People are bringing in laptops, notebooks, tablets, smartphones, things like that. So most companies have a policy that if you bring a device and you plan to use it on our business network, it has to go through IT, and IT has to put certain security software on there. Because you don't want the guy surfing porn and bringing that laptop into your company. All right, and there's tons of online collaboration tools. There's one called Slack. They're advertising pretty heavily now. But Cisco has a bunch of, WebEx, which was bought by Cisco. And Cisco is notorious. Years ago, Cisco was like the leader, the pioneer in stuff. Cisco invented, IGRP for routing, which back in that day there was only RIP. So IGRP was like an amazing feature. But since then, they've kind of gone the way of, hey, we're just going to buy what we need. So Catalyst had really good switches, so Cisco bought them out. And WebEx had a really cool product, so then Cisco goes and buys them out. Then they put the Cisco label on there, like, hey, look, we're Cisco. So I don't know. Maybe I'm just losing my fandom for Cisco. Maybe I've just been doing it too long. Anyway, I digress. And then obviously we have video communication. Cisco's telepresence and stuff is top notch, but it's very expensive. Then we have cloud computing. And this is another trend that you're going to see. It used to be we, as a company, we always bought a new server every time we needed something. So when I needed email or when I needed file services or backups, I bought new servers and put them in my business. And then I had to have a server room, which then I needed new cooling, and then I needed using maybe backup power or maybe a battery backup, something like that. So it was very expensive for companies. But nowadays, they're pushing it all to the cloud. Why do I need, like the college where I work, they actually get their email through Google Mail. That way they don't have to host a web server for 5,000 students. And nowadays, when you look at licensing, when you buy Microsoft Exchange for your email inside a company, you have to buy the Exchange license, then you have to buy a client access license for everybody, and it just the the amount of electricity to run the server, to cool the server. Cloud computing is really taking off, and that's why there's going to be a lot more jobs in data centers than there are going to be in regular companies, because a lot of companies are moving their stuff to these data centers. So when they say cloud computing, that's all they're saying. They're just saying, hey, the servers are not in my company anymore. They're hosted somewhere else. They're at the Amazon cloud or the Google cloud, or maybe a data center that's in your area. And there's public clouds, private clouds, hybrid clouds, and custom clouds. In my area, there's a place down the street that's a data warehouse, and that's typically where we send our clients. So if they want to move something, and that way, if there's an issue, they're still close enough. We can go there and work on their servers. But with this data center has redundant power, and it has redundant cooling and things like that. So the servers are never going to go down due to that stuff. It's always going to be a mechanical failure if they have issues. All right, moving on. So then they talk about technology trends in the home. And this is just another booming area where people need IT people or networking people, because now we have the smart home technology that links everything. Starts your car, opens your garage, heats your home, video. A lot of people have video surveillance systems so that they're at work, they can actually see their house and see what's going on. All right, they mentioned this power line networking, and for the life of me, can't understand why they still talk about this. This was a trend like a long time, like I want to say 15 years ago, where they were selling these things. So basically, you used your power lines as networking lines, and then you plug your stuff into these power lines, and you had these little blocks that would plug in. And I've never known this to be reliable. Like anybody that's ever tried this has always had bad experiences. But I guess, like I live in a split-level home, so there's a part of my house that doesn't have an attic and is sitting on a cement slab. So there's no way like I can get a cable normally, through into the walls, unless I start ripping out drywall. So that might be an option, but I've never heard people having any kind of luck or serious bandwidth through power line networking. I mean, think about it. Your data is going through the same lines as the electricity. It's just going to be bad. Anyway. All right, so there's wireless broadband, and basically what happens, companies rent space on cell towers or tall buildings, and they start pushing out wireless, and then they connect to a local service provider, and they start selling their bandwidth. And in some areas, this is really neat. So basically, they'll come around like to their area, their service area, and they'll come to the doors, and they'll have signs, hey, wireless, $8.99, stuff like that. So if that's available in your area and you're not a heavy internet user, and you're not downloading stuff all the time, you're just using email and internet, that's fine. All right, and then obviously security threats are always an issue. You always have to think about, where am I getting my internet from, what sites am I going to, and who's using my network. Especially if you have kids. Kids today, they are so susceptible. Like, they believe anything. Somebody's like, hey, click here and you'll get a cookie, and they'll click there. There's a website where you can download more RAM, and people believe it. It's nuts. You can't download more RAM from the internet site. Awesome. All right, so security threats, all kinds of different stuff. So a virus, worm, and Trojan, we kind of know what that stuff is. Spyware, adware, that kind of goes without saying. A 0-day attack is like, it's the first day of a new attack, so there's no defense against it. Anytime a new virus or a new exploit comes out, it has to come out, and then companies need to know about that, and then they build a defense against it, and then they push it out to their stuff. So the first couple days, you're typically vulnerable to a 0-day attack. All right, then there's denial of service attacks, where they start hammering your internet for something, so nobody can get to your web page. Then your sales kind of dry up. There's identity theft, all kinds of stuff. Then there's internal threats, and again, keyloggers nowadays are crazy small. You can, as a cleaning person, you're at a company at night where nobody's around, you can go to every PC and pop in a keylogger, and these keyloggers will actually email all the keys that you type in through the PC right out to the internet, and then to you, to the bad guy, who then knows everything that you're typing in on your PCs. And they're very small and hard to find. Let me see if I can find one for you. Yeah, so here's one on eBay. So this would plug into your PC, and then you would plug in the keyboard into here, and look how small it is. That's probably like an inch long, maybe. And who's going to look at the back of their PC at a business and notice this little attachment onto the keyboard attachment, or the keyboard plug-in? Probably nobody. So internal threats are just as big as external threats, but for some reason companies don't believe that. I don't know why. There's also a cool site called mapnorsecorp.com. That kind of shows you like the world and like where attacks are coming from and where they're going, things like that. I've always thought that was kind of neat. I don't really know a whole lot about it, but it's kind of cool to look at. And it's really neat in presentation. You're like, hey, look at this, and look how America's being attacked. All right, so security should be implemented in layers. You should have different layers. You can't just rely on just your firewall as the one security device. And different antiviruses typically get attacked. Like Norton and McAfee used to be the two biggest antiviruses out there. But because of that, everybody would design their viruses and stuff to get past Norton and McAfee. So you had to have we got a virus one time in a place where I was at, and we had Norton Corporate Edition, and it was all updated. All the PCs were updated, and more than half the PCs got hit. And the first thing it would do is it would disable the Norton, and then it would just infect the PCs. So we ended up getting some, at this time, Sophos was a kind of an obscure UK thing, but it was the only solution we found that worked. So then we had to scrap our Norton and go buy the corporate edition of Sophos, which is a pain in the butt. So again, larger networks have additional, and it depends on where you work at. Like if you're in a financial business or a healthcare business, if you're at a hospital system and some senator comes in for some kind of whatever his medical working is, for some reason all the bad guys want the senator's medical files because they want to find out if he has AIDS, does he have herpes, what's going on. So there's a lot of different things that you can do that we'll talk about through the CCNA program. ACLs, access control lists, internally to kind of block traffic from different networks. There's intrusion prevention systems. There's virtual private networking. And there's ways to encrypt internal traffic as well. So that's what we're talking about, layers. You want to have multiple different layers, like an onion. Cisco architecture, blah. So Cisco wants to sell you a whole bunch of stuff. And then, I don't understand this slide at all. They're saying for the CCNA, you need the CCENT, and then you need a second exam that they don't even give you the name of. And that's not necessarily correct. And this is the way we've always remembered it. So on Cisco's side, you can either take two tests, the ICND1 and the ICND2, or you can take just the accelerated test, the CCNA. And they don't even list that stuff here on Cisco's site, so I don't know where that slide came from, what kind of crack they're on. I think that first CCENT test is really basic because again, and it's not listed anywhere on this stuff. So if you go to an academy, you have the 4 classes. The first 2 classes kind of correspond to ICND1, and then the second 2 classes correspond to ICND2. So I digress. All right, and then obviously you want to think about what kind of jobs are in your area. I know at our college we have about a 70% of our students have a job in the field before they graduate. When you think about networking, everybody has a server. Everybody has computers. They all need a network guy to tie that stuff in. Although it's a lot of places, they just want a server guy or something like that. The smaller the company that you work for, the more stuff you'll be doing. So in big companies, they tend to specialize. You might just be the Cisco guy, and you may have 3 routers and 2 switches under your command, and that's it. And those are the only devices you're allowed to touch. Or you might be the server guy, and you might have 3 servers that you're responsible for. But in the smaller business, you'll be the jack of all trades. Like the one place I worked at was a medical foundation with 50 doctors. It was a multi-practice site. I was everything. I was the firewall guy. I was the contract negotiator for phone lines and data lines. I was the server guy, the router guy, the switch guy, everything. And I had 2 guys that worked underneath me that did different stuff and handled kind of the basic PC stuff. So you kind of get the idea. But so obviously you want to research jobs in your area. Maybe IT's not for you. All right, and that kind of wraps it up. But before we do that, there's a video called Warriors of the Net. If you've never seen networking equipment, or you've never you kind of have no idea what a switch or router does, this is a really neat intro movie. So just go to www.warriorsofthe.net, and that'll take you there, and you can kind of watch that movie. Now, I gotta warn you, it was made in the 80s. So the graphics are kind of cheesy, but it's a really neat video that I tend to show in my classes, so people understand how data moves across the network and what the role of each device is. All right, and then they talk about exploring the network. Make sure you know about what these 4 things stand for. blah, and make sure you know what all these terms are. I think I've covered all these in this video because it's like, holy crap, almost 50 minutes. But if for some reason there's something that you don't understand or whatever, just drop me a comment in the comment section. And other than that, Ray Cisco.